All right, as we're getting deep into the course here in general chemistry, a lot of background information is going to come into play. So we've talked about types of reactions and how to do unit conversions and a bunch of other things, how to write formulas from names of compounds. And so now we're going to put a little bit of that together in the dreaded limiting reagent problem. So this was a recent quiz question for my class where I gave them an amount of an aluminum reacting with the amount of silver nitrate solution, and we want to see like how much product can we make, how much solid product can we make, and how much of which material are we going to have left over. So here we go. We have aluminum, which is a pure metal, so it's going to be solid. And we're going to chuck that into a solution of silver nitrate. Nitrate is NO3 minus 1. Silver is Ag plus 1, so we need one of each to balance the charge. And all nitrates are soluble. So the state indicator is AQ for aqueous. We throw these guys together. The aluminum is more active. So when we see a pure metal reacting with a compound, we consider possibly a single displacement reaction. And in this case, since the aluminum is more active, we'll end up with an aluminum nitrate. And because aluminum always takes on a charge of +3 in its compounds, aluminum nitrate is going to be 1 aluminum with 3 nitrates. And that is going to be soluble because all nitrates are soluble. And then when the silver goes out and gets displaced, that'll make the pure metal silver, which will plate out as beautiful, shiny substance. Right, so the first step in any limiting reagent problem that I've ever done is we want a balanced chemical equation. So if you didn't know why I was writing out a balanced chemical equation, it's just the way that chemists describe the world. So the aluminum is reacting with silver nitrate. Now we have to balance it. We have 3 nitrates in the aluminum nitrate, so we're going to need 3 moles of silver nitrate to provide those nitrates. That's going to provide 3 moles of silver there, and then we're going to need the 1 mole of aluminum to be put in. We don't have to write the ones in, but I usually like writing in every coefficient for emphasis and to show that I've sort of thought about how much of each material. So here's our balanced chemical equation. 1 mole of aluminum would react with 3 moles of silver nitrate to give 1 mole of aluminum nitrate and 3 moles of silver. Balanced chemical equation. The second step, you want to understand that what you're trying to do is convert to moles so that you can work with the coefficients of the balanced chemical equation, which are mole amounts. So 1 mole of aluminum reacts with 3 moles of silver nitrate. You need to have your amounts of material in moles. The aluminum is already given to us in moles. So whoever wrote this problem was being nice to us and gave us the amount of aluminum in the right units to work with. So we don't have to do anything with that. Some people memorize the first step is to divide by the molar mass. They divide this by the molar mass and get some nonsense. But if you know that globally what you're doing is converting to moles, then you know if you were given moles, perfect, you've already converted to moles. Now for the other thing, the solution, we have a volume and a molarity. So hopefully you remember molarity times volume is the way you get number of moles for a solution. So 8.30 liters of silver nitrate times 0.1065 moles per liter. Right, so 8.3 times 0.1065 gives us 0.884 moles of silver nitrate. All right, so that's the second step, convert to moles. And I did a video with sandwiches that went through these steps with something that's more familiar so you can understand these steps. If you're having trouble following what I'm doing here, you might want to watch that video and see if you see the similarities. So the third step is we're going to use the mole ratios. And this is a classic limiting reagent problem where we're going to ask ourselves, if we use all 0.322 moles of aluminum, then how much silver can we make? Because the question here was, how much solid product are we going to make? So we want to figure out how much silver we get. And for each mole of aluminum, we get 3 moles of silver. So that's what this tells us. If we use 1 mole of aluminum, you get 3 moles of silver. We use these amounts to construct the mole ratio, 3 moles of silver per 1 mole of aluminum. Now we can convert from moles of aluminum to moles of silver. That'd be 0.966 moles of silver would be the product if we could use all the aluminum. We don't know yet whether we can. And then 0.884 moles of silver nitrate times we get 3 moles of silver when we use 3 moles of silver nitrate. So times 3 and divide by 3. Hopefully you're not taking your calculator out for this one. 0.884 moles of silver would be produced if we could use all the silver nitrate. So it looks like we pick the smaller of these two numbers. We don't add them up. We can't make all this stuff. But once we reach 0.884 moles of silver, we'll run out of silver nitrate and the reaction will stop. So that's why this is the limiting reagent or reactant. And that is how much silver we can make. Now the bonus part of this question was how much of what is going to be left over, right? How much is going to be left over? And so to do that, we need to figure out how much we used. If the limiting reagent is silver nitrate, then that means the aluminum is in excess. So even though we started with less of it, the aluminum is in excess. We're going to run out of the silver nitrate. We're going to have the excess aluminum. So for the aluminum, we had 0.322 moles to start. Now we need to figure out what we used to find out the leftover. And the key is always how much stuff did we make. So we figured out we'd make 0.884 moles of silver. And we used the same ratio that we used before, except now we're doing it backwards. We have 1 aluminum will give us 3 silvers. That allows us to convert the same ratio from silver to aluminum. So to make 0.884 moles of silver, we need to use 0.295 moles of aluminum. Right, so now we can put that here. 0.295 moles of aluminum is used. And so start minus used gives us leftover. So I have 0.027 moles of aluminum left over. And a final step is usually we want to weigh things and find out how much product we had left. So if we have a chunk of aluminum left at the end of the reaction, we're not going to be able to look at it and see how many moles it is, but we can weigh it and find out how many grams it is. So if we do 0.027 moles of aluminum times 26.98 grams per mole, so the number of moles times the molar mass gives us the mass, 0.728 grams of aluminum will be left over. And then in terms of the silver, we made 0.884 moles of silver, and that is really heavy stuff. 107.9, I believe. Let me check the periodic table. Yep, 107.9 grams per mole on the silver. So 0.884 moles times 107.9 grams per mole gives us 95.4 grams of silver. So that's how much we made. That's how much of the leftover we had. And if we knew how much mass we started with, we could compare to how much mass we would have in the end. Of course, we haven't figured out the mass of aluminum nitrate we're producing, so that's an unknown right now. But that's how to solve this problem, to find out how much silver we produce and how much leftover reactant we have at the end. So pretty sweet, and if you can convert units and you understand the idea of stoichiometry, then this is pretty straightforward.